Hello, hello, hello. Welcome. It's been so long. Um, I'm studying PYC 3704. And okay, I've spent forever thinking, okay, I can't do any Zooms because I want to be able to draw the math. And I got down a whole rabbit hole about that, and it can't be done practically at the moment, drawing the math, to record this for YouTube. But what I found was I discovered ALISON has free courses, um, and that's amazing. And you can go and get familiar with the math with ALISON. And then if you use ChatGPT, you can tell ChatGPT to give you simple problems to solve. So you watch ALISON, then as you're doing it, you create extra problems and solve them using ChatGPT. And that way you can get, oh, I can do the math. I'm confident with the math. I'm able to do the math and then come back to the course. So because I couldn't get our study guide, um, okay, it's here. I couldn't get the psychological research study guide until the course actually opened, which was a real handicap because when the courses are open, I normally am too busy working to actually study. So now that I have the course, I thought it would be nice to walk through it page by page, and let's see if that is helpful. So I'm just looking at the introduction where it says that this, and this is beautifully written, it says that this module is conceptually dense. That is, it is based on an intricate network of very precisely formulated arguments. So you need to not just memorize and summarize, but also understand the arguments in detail. Okay, that's true. The other thing that's true is that you can approach math as a language. In other words, it's a skill, and what you want to do is you want to move the skills from thinking and being smart and cognitive to automatic. Just as we can do basic arithmetic without having to think, you want to move some of the simple math of probability from, oh, this is really exciting and deep, to, yeah, bum, 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 and without having to think about it. All right. So we've got 6 topics. First, a general introduction, the meaning of the terms, and how data is produced that can be analyzed. Then, the notion of probability. Then, how we create hypotheses so that we can use data to test them using probabilities. Okay, so hypotheses, data, probability theory, all coming together. Topics 4 to 6 are applications and procedures. So some of the statistical procedures and tests that have been developed to test the hypotheses. Okay, so we're going to be looking at comparing a sample mean, which is a sample average basically, with a specific population value. Okay. So looking at a sample representing a population. Then we're also going to compare the group means from 2 samples, so each average, and how do we compare them? How do they fit together? How are they mathematically correlated? Okay, then topic 6, introducing correlation and showing how to test for relationships between 2 variables. Okay, that was what I was talking about. Okay. And there are appendices. And we do need to look at them for the exams. So that's very important. Okay, so here we are. We're being warned, heads up. Always know the appendices in the study guide, the PYC 3704. Okay, now each topic ends with a set of exercises, multiple choice questions, and solutions. So we get a bit of practice. You can, for free, find old exams, and I always like to go through them before I actually start studying, but today I'm jumping straight in. Okay. You want to do even more exercises. For me, that's always been the secret, is to over-test myself and to do several tests. But by now, you're in third year, you know how to do this. All right. Okay, and they also advise that we should be doing that. Okay. And don't mark, so they suggest don't mark this the correct answers in the study guides for that very reason. So you can do it again and again. Okay, so there's little icons. Summary, take note of this, do an exercise, beware. Beware of a potential pitfall or problem. So this is beautiful, beautiful teaching. Yay, this is exciting. Okay, so let's see. Let's start with topic 1, quantitative methods in research psychology. Okay, the word quantitative, okay, there's quantitative and qualitative are the opposites or the two categories that we put things into. Quantity has to do with amounts and numbers and measuring. Quality, like the quality of life, this is more amorphous, it's subjective, and we get it through interviewing people and giving them surveys and things. Okay. Okay, so let's see. Quantitative research constructs explanatory concepts that are abstracted from observed behavior, phenomena, and events. Okay, abstracted when you take something from the concrete into the theoretical. Okay, and how they form the building blocks of theories. You learn how constructs are turned into variables through measurement. So in other words, constructs are like theoretical hypotheses or theoretical ideas, and variables are data points that can be measured, and the two become equivalent. So you turn a thought, an idea, into something that you can measure as a variable. Okay, so how do we measure and how do we collect data? We collect data by measuring a representative sample drawn from the population that is being studied. And this necessarily leads to measurement error. So for example, there's constant polls and samples taken before elections, big elections, and there's always measurement errors in those samples. It cannot be identical. Okay. A research hypothesis. You also learn how a research hypothesis is formed as a clear statement in terms of a relationship among the constructs and the variables by which they are measured. Okay, so there's 5 parts to topic 1. Quantitative research, constructs, how constructs are made visible through measurement. Made visible through measurement is an important phrase to remember. Collecting information by sampling data and the research hypothesis. Okay, so 1.1, quantitative research. Defining psychology, a discipline that endeavors to collect information and develop theories about human behavior and mental processes. So, discipline, collect information, develop theories, human behavior, mental processes. There's 5 aspects to that definition. Okay, what are they? Let's see if you can remember that. Okay, yes, a discipline that endeavors to collect information and develop theories about human behavior and mental processes. Okay. Okay, so it's collecting facts that are related to psychological phenomena. Facts that are valid. Valid means that not only is it true, but it's logically connected to other ideas so that you can form a theory. Okay, so validity includes truth and logic and can be justified on scientific grounds. Everything that psychologists know about people, about their behavior, cognitive processes, and emotional expressions comes from research of some kind. So behavior, cognition, emotion, measured scientifically. Okay, so how do we get this? How do we do this research? And this is an introduction course. So we're not going to go into deep math. All right. Although math is actually central to this kind of work, not just in psychology, but in engineering. And it's interesting math. Okay. Interesting and counterintuitive. It doesn't work the same way that our natural, innate mathematical awareness works. Okay. So careful observation. Knowledge based on observation of physical events is referred to as empirical knowledge. Okay. Empirical, based on observation of physical. As distinct from knowledge based on thinking, insight, mystical experiences, or claims by authority figures, which are all forms of knowledge. But just seeing things and collecting facts is not enough. It's not sufficient. The next step is to go into developing explanations. So collecting quantitative information, knowledge, then developing explanations. Why? What are the facts, and why? These are theories. Theories explain why. Okay? And how. We're also interested in how. But the theories are about why. So for thousands of years, people have been, since the ancient Greeks, trying to figure out what is real and what is true. And this is the cumulative, what we're doing has a lineage of thousands of years old, which is really cool. Okay, so we're going to be looking at inferential statistics in quantitative research. Quantitative methods, when you turn data into numbers. Okay, and an inference is a conclusion that follows from existing information, generalizing from the specific to the general, in which you are not completely certain of the conclusion. Okay, so inferential statistics are techniques for making a generalization that are probably true. So they're not going to take us down the math rabbit hole, but I suggest you overstudy the math. Well, that's what I did, so that I feel in control and so that I know my brain isn't straining. It's not high revs when I get to the math. And also because it makes me feel less helpless to be told things that I don't know how to apply. Okay. And they gave a recommendation for a lovely arithmetic book that I have lost. Okay, and helping us to develop some discernment, so we're not completely manipulatable by people who say, oh, it's scientific. Okay, so now moving on to constructs. So I'm actually going to stop this recording and start another video. So I'll see you in the next video. I suggest that you go through and summarize what you've heard. Okay, I'll see if I can get an AI summary for this as well. See you in the next video.